failover ready status for these clusters, saying whether one cluster is ready to failover to another, and then we can initiate a failover from Eyeglass. We can, if we have time, maybe we'll update DNS and show resolution to the new host. I think all the steps that we'll see will be pretty clear. We may not have to do this, or it may not be that informative, but sometimes it's pretty fun to just to see it go end to end and resolve the host. And then finally, I'll show you a bit about the Runbook Robot. This is automated failover testing that happens on a schedule. And nightly, I say, but it can be any type of schedule. It goes, as you want to set it, and you can also run it on demand to test your failover, like actual failover capacity. So, going to Eyeglass, this is our normal, Eyeglass appliance here. First thing, I always like to start with the inventory view. Here's the 3 clusters that we've inventoried. You can, navigate through them and see the configuration. They all have more or less the same top-level buckets. Different ones have different, shares and exports, this type of thing. We can look at, this one's got a few shares on it. A few of them are in the offsite zone, a few of them in the system zone, and they're kind of spread out. And there are SyncIQ policies that are set up between them, and they have quotas, and they have exports, and they have aliases. From here, the next thing I'd like to do is go to the jobs window. So when Eyeglass gets a new managed device, it will go and it will inventory the whole thing. Shows up in that inventory view. And from the SyncIQ policies that it detects, it's going to build configuration replication jobs. This means that for every SyncIQ policy, it will take the shares, exports, and aliases from the source and copy them automatically on a 5-minute schedule to the target based on that SyncIQ policy. It will also build...
Excuse me. What do you mean by aliases? Zone aliases?
By not zone aliases, sorry, like NFS aliases.
Oh, okay. Yeah.
So zone aliases, in fact, do get copied over on the failover, but for the regular config replication process, we're talking about NFS aliases.
Okay.
Just kind of it's a catch-all phrase for me, I guess. Shares, exports, aliases. Yeah, that's what we mean there. So we can look at the the status of a job. This is a Runbook Robot job. Maybe we'll look at this policy one. And it's got a lot of information here, but you can see which one is the source. You can see the path. See the last success and some networking information. This I'm going to gloss over a little bit here in terms of what all that networking info. I'll come back to that in a minute. There's different ways to look at it here. So for each SyncIQ policy it finds, it also builds a quota job. Quotas we don't run on a schedule. We only run them on the actual failover process. That's why they're still pending. They have not yet been applied to the destination, but they're ready. They're ready there to be applied, and the job is kind of sitting in a pending state. I'll show you a little bit more in a second about how we know if this is, in fact, ready or not. This is the job status that we're looking at right here. We have a new job type that we've defined for this release. It's Failover Readiness. So for each pair of clusters, you can see big 1 to big 2, big 2 to big 1, and between big 2 and cluster tile A, we have a Failover Readiness job that runs, and it will decide, it looks at many different factors that I'll come to in a second, and it will decide, is this configuration ready for failover? This is something we've been putting a lot of work into, and it's kind of the, it makes it easier for the end user to see, am I ready for a failover? And instead of, just kind of clicking and hoping, right? This way we'll know, they can know in advance if anything is not configured properly and can take steps to mediate that particular setup. These are the Runbook Robot jobs that get built. I'll talk about those after we're done with the failover. And we have also access zone replication jobs that can take access zone related information and synchronize it to the target if you decide to. From here, we can look at the Adr Dashboard View. So the Adr Dashboard View is where we're going to go to find out information about, are our policies ready for failover and are our zones ready for failover? We define two different types of failover for this, this product. So we have a per SyncIQ policy failover. This will fail over the SyncIQ policy. It will fail over all of the shares, exports, NFS aliases, and quotas, but will not do any of the associated networking related to that. The networking information gets populated or gets failed over in an access zone failover. So to that end, we have two different types of readiness. We have policy readiness, and we can see here, which ones are ready, which ones are not ready. This one is the Runbook Robot. Again, let's look at this one, the mirror policy. So for policy readiness, we check that SyncIQ job, the actual Isilon cluster SyncIQ job, has run and was successful last time it ran. And we also check our own configuration replication job. We see that last time we ran configuration replication, it succeeded, and we did an audit on it, and the audit succeeded. At this point, we're confident that the source and the destination are in a state that if we were to fail over this policy, it would fail over successfully, and that all of your configs will be successfully applied on the far side. With this one, let's look at the offsite policy, and this one, you can see it has an error. Right now, our SyncIQ job has never been run, and that we do run it during the failover, but we would encourage users to run their SyncIQ policies before the failover, just so that the failover takes less time. And, there's less chance of anything going awry. But our config replication between the source and the destination is okay. Now, if we look at zone readiness here, we have different a source cluster, target cluster, and a zone name. First of all, let's look at zone replication from source cluster big 1 to target cluster big 2 for the system zone. This will be the easiest one to see. We have a network mapping. I'll come to this in a second. This is for the network pools. But first, let's look at the overall status. If I click that, you can see we have different criteria for determining that a zone is ready to fail over. First one is policy readiness. So our zone has a few policies in it. These policies are all okay, as defined on the previous screen. We make sure that config replication for all of these policies and in the zone is okay. We look at the Smartconnect failover mapping. This is something that we have put in place to define a mapping between a source pool and a destination pool. Users are required to configure their clusters in a way that will they'll place an alias on the subnet pool or the network pool in a subnet, defining when I fail over, I want this pool or I want the networking information from this pool to be attached to another pool on the target. So since I've done that on these clusters, my status shows up as okay. And zone configuration replication job is good for this particular zone. If we'll keep this one up, and we'll look at this this one that has an error. So I mentioned that I haven't taken all the steps for Big 2 to Kyle A, the offsite replication. I'm going to bring this one up, and this will tell me, if I want to fail over, I'm not ready right now. So as we saw on the previous screen, policy is not ready for failover. And if I click it, it just tells me it has an error. You can go to the other screen or to the alarms to find out why. And I also see that my Smartconnect zone mapping has an error. So I haven't set up my pools. I have pools on the source, network pools on the source, but I haven't set up a mapping for them. So if we're to fail over the access zone, Eyeglass has no way of knowing which network pools on the target we would want this to be associated with. So it's saying you have an error, and please go and provision your mappings according to the documentation so that when we do the failover, we know which one this should go to. As I said, the network mappings are a big part of this. So for each source cluster zone combination, we pick out the network mapping that the user has defined. So our source cluster here, Kyle Big 1, in the system zone, I think it's actually informative to go look at the cluster itself, and we'll examine the networking here, and then we can see how that translates into the network map. So that is this one. Logged out here. And let's go to cluster management network configuration. I'm going to look at my default subnet. So I have 4 pools set up here. I have pool 0 in the system zone. It has this zone name. I have pool 1, has this zone name. And I have my SyncIQ pool. And one of the sort of caveats of this release is that when we're doing the failover, we want to know whether we should be failing over or not failing over some of the networking pools. And best practice would be to put your SyncIQ traffic and policies into a particular network pool, and then this one will not be failed over based on the mapping that the user provisions. So all of the policies I have set up on the system are using these Smartconnect zone names in the policies rather than a straight IP address to resolve the target cluster. So these 3 pools are in system zone, and these first 2 pools I want to fail over. If I'm initiating a failover, I want them to go. So if I go and look at my network mapping here, I can easily see what's been provisioned and how my network mapping is set up. So I know that from my source on Kyle Big 1 going to my target on Big 2, I have this subnet pool 0. It has these aliases on it. It has this zone name, and it's going to fail over to subnet pool 0. And similarly for pool 1, it's mapped this way to subnet 0 pool 1. The way we identify this is by putting this alias on the pool itself. So the alias takes the form of igls-mir- as a prefix. Then we have target cluster name dot target pool name, target subnet name dot target pool name. This structure allows us to fan in or fan out. It allows us to choose different source and target Smartconnect zones for failover or pools for failover. And you can see this last one here has a prefix of igls-ignore local cluster name, local subnet name, and local pool name. In this case, we detect that for this is our pool for SyncIQ traffic, and the user has told us that we do not want this pool to be failed over. And here we indicate that to the user. If we look at the network mapping, yeah.
When you're saying the pool gets failed over, does that automatically mean that you're taking over the IP addresses from cluster A to cluster B?
We're not taking over the IP addresses. We're taking over the Smartconnect zone names and Smartconnect aliases.
Okay.
In fact, this you don't want to do a demo cold, right? So I actually have failed this one over this morning, and so we're looking at a pool that has been failed over. So right now, this Smartconnect zone name before the failover used to be Kyle1.81.test. During the failover, we took that Smartconnect zone name and applied it as an alias on the far side, and we renamed this to be igls-original. We didn't want to delete the Smartconnect zone name. We just put a tag there so that we can reconstruct it. So what I'll be showing you later actually is a failover in the other direction from 2 to 1. But you can see, and maybe let's bring up the mapping in the other direction just so we can compare.
But the IP addresses just remain as they are. They are configured on each cluster, and they remain where they are. Yeah.
They remain as they are, exactly. And then we rely on the user going to DNS and pointing the the Smartconnect zone name to the Smartconnect service IP on the right cluster. So there's a manual step after failover happens to modify DNS. So if I look at,
it's useful to point out that much of what you need during the failover, because there's lots of IPs and things to know what to do, it's basically all right here on this one screen, everything you need to know. So the SSIPs, the from, the to, we did also want to look at, here's the DNS syntax of what you need to fix down the road as well.
Okay.
So if I look at kind of the difference between the network mapping in this direction from 1 to 2 and the network mapping from 2 to 1, I can see that, you know, here from 2, my Smartconnect zone name, my source is, you know, is Kyle2, and I have a couple of aliases here. When I go back in the other direction, this Kyle2 will get provisioned as an alias on this side, and will detect that this, you know, Kyle1.81.test really belongs as the Smartconnect zone name, so we'll restore that. So, you know, DNS queries would go, and the right cluster on the right side will respond. The last thing I want to point out is that we have this one that's an error over here. Maybe I'll close this just to clear some space. Oops, that was an error, and we want to view the map for the error. So as I mentioned, I haven't provisioned any aliases here. So this, you know, very effectively tells the user, I found 2 subnet pools and they don't have a target pool provision. I want to fail over this way, but I don't know what to do with these pools. So, you know, I can't, they're not going to fail over at this point in time. So this is the configuration that's been set up, and what I want to point out is that in Eyeglass, the steps that you have to take to make this happen are very minimal. All I've done, really all I've done to the Eyeglass appliance is to go to the main menu and add a managed device. Here I added my Smartconnect service IP, username, password for the Isilon cluster. I did that 3 times, and then after that, Eyeglass did its thing. It picked up all of the inventory, it created the jobs, created the zone readiness job. It determined if my cluster was ready for failover. And you know, this all kind of just appears at the tip of your fingers. There's very minimal configuration for the user to do on the Eyeglass side. There's a bit of provisioning to do for the network pools. That's a kind of a one-step operation. And as soon as you do that on the network pools, on the next inventory cycle, happens in 5 minutes, Eyeglass will pick up that information and these statuses will auto-refresh, and it just, you know, shows you, am I ready, am I not ready? So with that in mind, let's do a failover. So we've put a lot of work into the guided failover wizard. You can access it here on the desktop. I'm going to kill that one for now and bring up the guided failover wizard. So here, I want to make hi.
Yeah, I'm sorry. Before we do the failover, can we have a look at the SPNs? Do you take care of SPNs too?
We do take care of the SPNs. So let's look at on cluster 2. I have, you know, I have no missing SPNs right now. So you know, the repair is done. All of my Smartconnect zone names and aliases have SPNs that are provisioned in DNS for this one. And I think, you know, I think for cluster 1, they're also okay in AD. Yeah, sorry. Yeah. Right. So at this point, at the start, we are in a clean state. If we go and look at the network pools on,
would you also take over extra SPNs? So I have a customer who has lots of aliases configured because he's still taking care of all the old NetBIOS names that he had in his environment. So he had created a lot of extra SPNs.
Yes.
Would that also be taken over?
Yes. So every alias that gets every alias or Smartconnect zone name that gets moved, created, updated, deleted, those operations do have associated SPN operations that go with them. If there are other SPNs on the system that aren't associated with the Smartconnect zone names that we detect for a particular access zone failover, then we don't operate on those ones. Okay. We just take we just take.
So the customer has to use Smartconnect aliases, not DNS aliases.
Yes. I'm not. I guess so. Yes, they would use a Smartconnect alias and then have that failover. Yeah.
Okay.
Yeah. So in our subnet 0 here, we have these pools, and actually you can't see the aliases through this this UI. We could do it on the cluster, but actually it's visible. Maybe it's most visible in the mapping in Eyeglass. I guess just to show you first, we won't execute this, but we can do one of two failover types, a full access zone or a single policy failover. And the first operation is to choose a source cluster. So I can choose, number 2. Here we have a couple of failover options. We have continue on error. This means, exactly what it says, right? If something goes wrong, please keep trying. Don't error out immediately. This can be useful in cases where, let's say, the SPN remediation does fail, and it's going to fail. We could still, issue the commands, and then there would be a manual process after to go fix up what has happened. Controlled failover is in the case where the source cluster is reachable. If the source cluster is unreachable, we can deselect controlled failover, and then only the operations that are targeted to the target cluster will be executed. We will still try and create the right zone names and aliases. SPN remediation will probably fail because there's duplicates, but we will migrate as much as we can, and then it's up to the user when the source cluster comes back online to take the final steps. If you are doing a controlled failover, we can create the mirror policies, or it's effectively executing resync prep on the source cluster. And if you do that, sometimes you want the SyncIQ jobs that you create, or the SyncIQ policies that you create, to be in a disabled state. So that this is a manual step that you can take. If let's say you have a schedule on your source, Eyeglass will take that schedule from the initial policy and will apply it to the mirror policy. Maybe you want that schedule to be applied so that it doesn't get lost, but you don't actually want it to run until you're ready for it to run. In that case, you would check this box.
Mm-hmm.
Finally,
but if the mirror policy already exists, it will just continue.
Yeah, exactly. So it will create the mirror policy if it doesn't exist, or it will use the one that exists if it's there. Finally, before we do a failover, we check the namespace for open files. Any open file handles, if there are, then we will stop the failover at that point and alert the admin or the Eyeglass user that we found these open files and we have elected not to continue. Sometimes, you want to proceed anyway, so you can force the failover if there are open files or open connections. So for me, I'm going to check continue on error, and I'm going to create my mirror policies, and I won't force the failover for the open files. And I guess we have single policy selected here. I'll just show you what that screen looks like. Here we can choose any of the policies we have on the cluster we have selected, and actually you can choose more than one, and you could fail it over if you want to. I think there's more steps that happen in the access zone failover, so we should do that one as the demo. So next, here we have the similar view that we had before. However, it's filtered for the source cluster, so we can pick any one of these 3 access zones. What I'll do for now, actually what I want to do is go back, continue on error, unchecked, and then so now we have not checked continue on error. I'm going to go forward, and I'm going to select a policy that has an error, and click next. So in this case, we're trusting that we've done the appropriate prep work, and here's a big warning, right? We're aware that there are some errors associated with your policy, and it's probably not going to succeed in its current configuration. So if you're aware of this warning, if you know, please go back, select continue on error, and then you can go back here, and now your next button is enabled. It gives you a different message. You can proceed. We're not going to stop you, but you may have to take some manual steps. This is not, however, the policy we want to fail over. We want to do this one. Selecting system zone will fail over all the zones on this cluster. That's okay. So we want to continue. This is actually going to, I didn't realize until right now, this is going to attempt to fail over this offsite zone. So we'll see what happens in the case of a failure also, and that's fine. So next, so we've determined that you're ready to go, and we'll submit our job. Great. So finally, we give you a summary. We have saying we're going to fail over these 3 policies. I've reviewed the above, and I wish to initiate my failover. So here we go. We're going to run it. And when it runs, now we get brought to our running jobs window, and we have this access zone failover. We're going to fail over the system zone. So in this case, we have a bunch of steps that will appear in this. They get populated dynamically in this tree. So the first thing we do is to fail over all of the policies that we detect in the system zone. We look for the policies there, and we only execute one policy failover at a time, wait for the open files to be closed. Here we're doing a final incremental sync of the policies. I'm going to make this a bit bigger so we can see. We are running these 4 policies. Some of them might succeed, some of them might not. That's okay. So right now we've run that policy. We're going to wait for it to complete, and then we're going to ensure success. These 4 steps happen in parallel with a limit of, I think it's about 10 concurrent. I don't know if the source cluster can handle 10 concurrent requests, so I think it's 5 actually that the cluster supports. Right now, looks like we've successfully run all our policies. We had a few failures. I'm going to disable my auto refresh for a second. We've had a few failures, so we can look at what the failures were. This offsite policy failed to complete, failed to run successfully. If I look at my info for this, it'll tell me probably that something didn't go correctly. This can be a little bit cryptic to parse. We probably have an alarm for it too. I'll go there in a minute. Right now, we want to, so we've done our final incremental sync, and the next thing we do is to run configuration replication. I'll refresh again, and I can show you what is in this configuration replication. Actually, it's up here, but after that, we do config replication, which does a final incremental sync of all of the shares, exports, NFS aliases. After that, we run the quota jobs. So in this step now, which is probably running if I refresh, we've done our quota failover. So we've taken all our quotas from the source and applied them to the destination. Our prerequisite has completed. So we've done, waited on the open files and final incremental sync of everything, synced the quotas, and now we're actually doing the policy failover itself. So our offsite policy has failed. That's okay. That's what we would expect. Some of these Runbook Robot policies may or may not succeed. We'll see. And the most important one that we care about here is this mirror policy. This contains our data and contains our shares. And if we look at the steps that we're taking, so first thing we do is query the policy to get the information, remove the schedule from it, allow writes on the target. You can see here these 2 operations were on the source. This allow writes on the target. We're going to wait for that policy to actually execute that allow writes command. Then we're going to execute resync prep. We're going to take the schedule that we pulled from the source and set it on the destination, or set it on the target. In this case, we're going from a mirror policy back to a normal policy called poly4. So we would take the schedule from the mirror policy and apply it to the original policy. Here, let's see, we're at still failing over the policies. These are, it takes a little while to run the full failover steps. There's quite a few operations you can see that are being executed against the source cluster, or against both clusters. And we are, automating all of those steps. It makes it quite easy for the user and, much less, I guess, error-prone for that type of operation. So now our policy failover for zone system has actually resulted in an X, but we can check out what happened. We failed over our policies, and we can see the mirror policies and the Runbook Robot policies. These failed over okay. It was our offsite policy that failed, and that's expected. In this case, we're happy to continue because we have these three mirror policies these three policies that we know are targeted from source to destination, and these are the ones that we want to fail over. At this point in time, we're failing over the networking. So there are source and target operations that we take. We rename the source Smartconnect zones and aliases. So we've taken subnet 0, pool 0, this alias, and renamed it to that. We've deleted this particular alias because it exists on the source. Remember, we had igls-mirror-kyle1 on the source. In that case, we deleted the alias from there. And we've done the same operation for pool 1 as we did on pool 0. For the SPN updates, we can see we wanted to delete SPNs for those things that we have moved or renamed. So we took this Kyle-2.81.test and renamed it. In that case, we have to delete the associated SPN for that. We deleted the alias for Kyle-1. We have to delete the associated SPN for that. Same with pool, Kyle-2 pool 1 and Kyle-1 pool 1. And the last step is to execute the repair command. I'm sure if I refresh now, our job is finished. We had a failure actually on the target operations. So we successfully renamed all of our source or all of our target Smartconnect zone names and aliases. We created the right alias. We renamed our original pool from what it was back to Kyle-1.81.test. We've created an alias for Kyle-2-P1 on the right pool, on pool 1, and our modify SPN command, we deleted those SPNs for the initial ones, and our repair command actually failed. We can look at the info. It just tells us that repair SPN command failed. Your operation at this point in time would be for a user to go in and now figure out why that failed. That probably should have succeeded. We can do a check here. And we can see that I guess these ones are still existing and these ones haven't been added. So the failure would indicate to the user that there's a manual step that has to be taken now to go in and figure out why that is. But this is that's kind of the full process for a failover. And at this point in time now, my source cluster, Kyle-1, is the hot one. So I really have failed over from Kyle-2 to Kyle-1. I can mount my data from the source cluster or from the Kyle-1 cluster, and it's ready to go. The thing that I want to say, this is like quite a complicated procedure, right? There's a lot of things, and some can go right, some can go wrong. The other interesting thing you can do is not to do this like on a one-shot deal, but to run it on a schedule. So this is where the Runbook Robot comes into play. The Runbook Robot is these operations, either for just a policy failover or for the full access zone failover. And you can do it on a schedule. So if you create a policy that's prefixed with Eyeglass Runbook Robot, then we pick it up and we'll apply, or we'll create a special job for it. So in the jobs window here, we have our Runbook Robot policies, and we can see I have two of them. Are ones from Kyle-1. I've called them Mr. Roboto. And if we want to execute one of those, there's some really interesting things that happen here. It'll be easier to talk to, I guess, if we just run it. So I'm going to run now. And yes, I want to run my job. Okay. Now if I go to my running jobs window and I refresh, I'm going to go to the top. I have my Runbook Robot. This does a couple things. So the first thing we do is Failover Preparation. We create an export on the system. So if I were to go to my source cluster and look at the directory for this Runbook Robot policy, I can see now I've actually created an NFS export on that particular directory. Our appliance is a Linux appliance, So we go and we mount that export on the appliance, and we write some data to this mount. So we take the current timestamp and we write it to a file that exists on the Isilon cluster, and then we unmount it. The next thing we do is to issue a SyncIQ policy failover for that particular this particular policy. So it will go, if I refresh it, I'm sure it's well on its way now. It's executing probably configuration replication at this point. Yeah, it's actually running the policy. So it takes the data that we wrote to the source, and then now it's failing it over to the destination. This will take 2 to 3 minutes to run. But once it's failed over, the final steps we do is in this failover validation bucket. The steps here will show up when we get there, but we remount the data this time from the target, and we read back the file that we have just successfully replicated. We ensure that that timestamp that we wrote to the file actually corresponds with what we set in the source, and then we write data to the file again to make sure that it is readable and writable. So in this way, you can test, the full kind of SyncIQ policy failover chain anytime you want. It's limited to the playground of the Eyeglass Runbook Robot policy, and if you put extra information, extra shares or export or quotas in there, those will get failed over. So you can have a really good way of testing the failover process from within Eyeglass before you actually have to do it on your live data, which is a pretty powerful thing. Further to that, if the Runbook Robot policy is in its own access zone, and that access zone doesn't contain any other policies, then we'll actually do a full access zone failover, including the networking, on your Runbook Robot policy. And so then you can verify that the failover is working, your mapping is set up, everything is good, and you can actually do a failover on a schedule. This will happen on a nightly basis, and it will send you an alarm if anything goes awry. Let's refresh and check. So it's probably still failing over right now. Should be finished pretty soon. Yeah, guess it's just waiting for the policy now. Shouldn't take too much longer. Guess we can enable our auto refresh, and we'll know when it's finished.
Does that also play the Mr. Roboto track in the background? It should do that.
If you want to. So it's doing these demos that I realize, when you're just testing or developing and you make funny policy names, maybe that isn't always the best thing to do. Make them sane, right? At least it's not anything too bad, but yeah. So that's more or less the failover demo. I think that's pretty pretty much what we wanted to see for the